Hello guys, and welcome back to my YouTube channel. In our previous video we discussed the quicksort algorithm, and then we implement the quicksort algorithm using C++, and then we execute our program and sorted this unsorted array in an ascending order. Now in this video we will discuss the concept of heap sort. Heap sort is a comparison based sorting technique based on binary heap data structure. It is somehow similar to selection sort, where we first find the minimum element and place the minimum element at the beginning and repeat the same procedure for remaining elements. Heap sort is a in-place algorithm. Its typical implementation is not stable, but can be made stable, typically 2-3 times slower than well implemented quicksort. The reason for the slowness is a lack of locality of references. Now, advantages of heap sort. First one, we have efficiency. The time required to perform heap sort increase logarithmically, while other algorithm may grow exponentially slow as the number of items of sort increase. This sorting algorithm is very efficient for data, for large range of data. Memory usage is minimal, because apart from that is necessary to hold the initial list of items to be sorted. It needs no additional memory space to work. And third, we have simplicity. It is simpler to understand than other equally efficient sorting algorithm, because it does not use advanced computer concepts such as recursion. So it is a non-recursive implemented algorithm. Application of heap sort. Heap sort is mainly used in hybrid algorithms like intro sort. The heap sort algorithm has limited uses because quicksort and merge sort are better in practice. Nevertheless, the heap sort structure itself is enormously used. So let's look at some keyword involved with heap sort. First, we have heapify. Heapify is the process of creating a heap data structure from binary tree represented using an array. It is used to create min heap or max heap. Start from the first index of the non-leaf node, whose index is given by n divided by 2 minus 1. Heapify uses recursion. Algorithm for heapify. So we have our heapify function and we passed it an array. Then the root, which is the 0th index of our array or the first index of our array. Largest is equal to the largest function, and we pass our array's 0th index and array's 2 multiplied by 0 plus 1th index divided by array's 2 multiplied by 0 plus 2th index. So if root is not largest, then we swap the root and the largest. Now let's take a look how heapify actually works. So we have this array, unsorted array, and the corresponding binary tree for this array will be this. The task to build a max heap from above array. So first we have the total number of node, which is 11. Then the last node leaf, node index 11 by 2 minus 1, and it is 4. Last non-leaf nodes. So these are the 4 last non-leaf nodes. Non-leaf mean they have no children. To build a heap, heapify only the nodes 1, 3, 5, 4, 6 in reverse order. So heapify 6, swap 6 with 17. Here heapify 4, we swap 4 with 9, and in heapify 5 we swap 13 with this 5, and heapify 3 we first swap 3 and 17 and then again swap 3 and 15. This 3 and 17, and then 3 and 15. And heapify 1 we first swap 1 and 7 and again swap 1 and 15, finally swap 1 and 6. So let's take a look at heap sort algorithm. To solve the problem, follows the below idea. First, convert the array into heap data structure using heapify. Then one by one delete the root node of the max heap and replace it with the last node in the heap, and then heapify the root of heap. Repeat this process until the size of heap is greater than 1. So step involved: first we will build a max heap from the input data. At this point the maximum element is stored at the root of the heap. Replace it with the last item of the heap, followed by reducing the size of heap by 1. Finally the heap the root of the tree. Repeat step 2 while the size of heap is greater than 1. Now let's take a look at working of heap. To understand heap sort more clearly, let's take an unsorted array and try to sort it using heap sort. So consider we have an array of 4, 10, 3, 5 and 1. We will build a complete binary tree from this. So this at first step we create a binary tree from this array. Then transform into a max heap. After that the task is to construct a tree from that unsorted array and try to convert it into a max heap. To transform heap into a max heap, the parent node should always be greater than or equal to the child node. Here is the this example. As the parent node 4 is smaller than the child node 10, this parent node is less than this child node 10. Thus we will swap them to build a max heap. Transform it into a max heap. So after converting our binary tree into a max heap, the 4 less than 5 and 5 is greater between the two children. So this is now our max heap. Here the parent node is greater than all of its child nodes, and now our array is something like that: 10, 5, 3, 4, 1. First 10, then 5, then 3, then 4, then 1. So this is our array of our this max heap. After successfully converting our array into a max heap, we will perform heap sort. Remove the maximum element in each step, move it to the end position and remove that, and then consider the remaining element and transform it into a max heap. Then delete the root node 10 from the max heap. In order to delete this node, try to swap it with the last node. In this example the last node is 1. After removing the root element, again heapify it to convert into a max heap. The resulted heap array should be something like that. After we remove the max heap and replace it with the leaf node, now our array is something like this. And after heapifying it, it will convert into this. Then we repeat the above step, that it will look like the following. So now we have 1, 4 and 3, 1, 4, 3, 5. Then we remove the max element from our heap. Now we will remove the root in this example 3 again and perform the heapify. And after removing the max, our array will be something like this. Now let's try to implement this heap sort in C++. First let me remove the code of our previous example of quick sort. First I will write our heap sort function. Now for code for our build heap, I will use a for loop. Int I is equal to n divided by 2 minus 1. And then our I greater than or equal to 0, and then increment of I minus minus. Now I will call my heapify function and will pass it an array, size of array, and an I. Now we have not made our heapify function yet, but I will create it after this heap sort function. Next again our for loop, and this time our integer will be equal to n minus 1, and condition will be I greater than 0, and then the decrement I minus minus. Now I will call our swap function